In this video, we are going to introduce the products that you're going to work with. Then we will show you how to get a list of the products available on the platform and how to search and extract information from them. Finally, as a case study, we will write a function that rolls over a future at its expiration. The Algo contest covers all the futures and options of the Hong Kong Exchange Index. There are two major indices, the Hang Seng Index, SHI, and the High Share Index, HHI. Both of them have a mini version, respectively called the MHI, the Mini Hang Seng Index, and MCH, Mini High Share Index. There is a future expiring every month, and we have calls and puts at various strikes, also expiring every month. We cover the period of January to June 2016. For every instrument, you have the market data during the normal trading hours. So this doesn't cover the auction period or the aftermarket periods. And you have one sample per second. Each data record consists of either a bid-ask record, which contains the best bid and the best ask price and quantity, and you also have the trade records. So each data record is either a bid-ask record or a trade record. Now we will move on to the hands-on lab, and we will show you how to search and extract data from the catalog. And then we will show you how to write a function in order to roll over a future once it expires. Let's start by opening a new document and importing the CAFG library as usual. All the product data comes in an exchange catalog that you get by using the exchange catalog function. We will work with the exchange catalog number 3. Here I assign the catalog to a variable for later usage. Then you can get a list of products by using the list method like this. This returns a list of which every entry has the type contract def. There are many more contracts that are listed on the screen. Too many to display. You can get the contract def definition by using the help function like this. And every contract def has the following attributes. The order book ID is the unique ID that identifies this given instrument. It's an integer that we need to use whenever we want to refer to that particular product. After that, we have a class code, which is the code of the underlying product, so either HSI, HHI, MHI, etc. Future opt is the letter that indicates whether the product is a future or an option, so either F or O. The expiration code is the year and the month of the expiration of that particular instrument in the format year, month. So for example, we would have 1612 for December 16. It doesn't have the date. The day is part of the expiration date. Expiration date, as you can see, is more precise. It has YYYYMMDD. So for the same product, we would have 2016 12 29. The strike is the strike of the option, and 0 if it is a future. Call put is a letter that indicates whether the option is a call or a put. If it's a future, it would be a space, blank space. The price correlation factor is a multiplier. Essentially, it is involved in the calculation of the profit and loss. For every change of the price of the underlying, the effect is multiplied by this value. So, for instance, if we have 50, it means that for every change of $1 of the benchmark of the index, the profit and loss would be $50. The rest of the information, size, number decimal, so on, is not relevant for this competition. So you may ignore that. Basically, the exchange catalog is a table of products. Each row corresponds to one product, and each column is one of these attributes. Now we are going to look into searching and extracting data from the catalog. So I will start by assigning the list to a variable. So I would say products equal exchange.list. And now I can work with my list. So this is the products, it's the same thing as before. Since it's a list, we can use this comprehension, which shows up like this. You do product. This is the variable that you want to extract. So we're extracting the full row for the moment. And then there's another part, which is the loop part. Product for product in products. So this shows exactly the same thing. But we can further filter. So if we put a condition here, we can search for example, the future HSI of maturity July 16, like this. If product dot expiration code equal December 16. No, we said what? July 16? Okay, doesn't matter. So just say December 16, 1612. And product dot class code strip equal HSI. So this shows me every product of December 16, but if I want the future, I need to further qualify that with product should opt equal F. Now I only have one of these products. Now instead of just extracting the full product information, product row, we can extract just the product ID, the order book ID, by changing the first expression just like this, and this returns me only the order book ID. And obviously you can do any expression you want here. So for example, if I want to extract two values, the product ID as well as the expiration date, I can return a pair. Okay, moving on to the next topic, we are going to write a function that rolls over a future. So let's pick all the futures for HSI. We go back to this expression here, and we are not going to filter on the expiration code since we want all the futures this time. Just remove this condition, and we get a list of product IDs and maturities. So let's go back to extracting all information. So I get the product again, and assign this to a variable b equal this, and let's see how we can roll one future. So I would roll the first one as an example. We use the first one, and so far we assign to a variable. Right? Why not do something like this? And I want to write a function that takes a product, one of these p's, and returns the next one. So I expect something like def next future that takes a product, and that returns the next product. The first thing I would need from this, therefore, is to know the expiration of my current contract. So I can do ec equal p.expiration code. To roll a future, I don't need to know the date, so expiration code will be enough. For the expiration code, I know that the first two letters, well, two letters, yes, or 2 digits, is the year. So I can do year equal ec from 0 to 2, and month is ec 2 to 4, and I will print both month and year. Okay, and let's try this function by calling next future with a, and that returns 0616, which is expected month 6 and then year 16. But the fact that we have a 0 in front of the month leads me to believe that this is not treated as an integer but as a string. This is actually extracting the substrings of the expiration code and not the actual numbers. So I need to cast the string to an integer. So I simply have to call a function int that will convert that string to an integer. And if I call again, now I have this time 6 and 16, and these are integers. You can further try that, verify that by just simply adding 1, and this will show it as 7. Whereas if I didn't have int, I will get a type error because I cannot add a number to a string. So let's revert to what I had before, which was correct. And now work on incrementing the month. So we increment the month, and simply have to add 1. So I can do integer plus 1 right here. But obviously this leads to an issue when the month is December. So in the case that m is equal to 13, I need to roll over to the next year. So I will set m to 1 and increment the year instead. Let's see what we got so far. 716, which is correct. But let's try with the case where we need to roll over to the next year. We print p and look for the one that is December. So this is the last one. P9. Let's verify it's P9. Yes. And I will call. I will say A is P9. And then I can go back here and call this. And we see that it has rolled to to January 17. We need to form the expression code back for the next future. So this is basically the reverse of what we did right here. For this, we can use a format string like this: %d, %d, which are digits and digits, and then we are saying that we want to print the year and the month. So the year first and the month later, and print ec. If we do that, we get 1607, 16.7 and not 16.07, but we want 16.07. So we need to make sure that each part has at least 2 digits. So we can do %2, which would still have a problem because by default it would be padded with spaces, and the result is 16 space 7. To make sure we have 0 leading zeros, we have to do 0 to D, 0 to D. Technically, we don't need that for the year because the year is going to be greater than 10 now. But for consistency, it's preferable to have the same format string. And we can use the search criteria that we had before to look for a matching product. So I will copy that expression here and assign that to next future. Even though there should be only one, the convention is to use plural whenever we assign the list. It helps keeping track of the type of the variables. Let's change the expiration code condition to use the next expiration code and the class code to match the input class code. At this point, we should be able to print the next futures, and then we get a product code. Let's actually print the whole product, and we can see that it's effectively the next future. But this works with the first one. But what happens to the December one? In this case, there will be no matching products in the database, so we would get an empty list. Furthermore, we don't actually want to return a list, we want to return one item. And normally this is just one record, so it would be more correct to do next future of 0. But the problem is if we do this and there's nothing, we get an exception. So we have to handle that case and say that we put a condition. So we return the next future of 0 if the length of this array is greater than 0, else we return none. And we keep printing stuff. So now for the last one we got none, and for the first one we will get our right record. Finally, we don't want to print things, we want to actually return the product. So let's do the final change, which is to return the value. And yes, we have expected result here. So you can see that if the return is known, we get no printout. Let's put everything together and test it with this function on every product of our list of P. So using the same syntax, we can do next future of x for x in P, and this gives us an array that is a list that is a transformation of the original product list, but for each element we call next future. Let's see them side by side. So we have the original one is like this, and we see the first one is June, it became July, 5 becomes 6, and so on and so forth. The interesting ones are the ones that have gaps. So this one is the January became February. The September one should become October, but there is no October, so we got none. And the last one, which was December, also became known. So it shows that our function works as expected. So this concludes our reference data talk, and the next one will be about working with market data.